to have some definition to help you recover your data. So how to recover your data? Why we can recover your data? So if you call this, it means that it just play your file in the recycle bin. But you can use a zip delete to permanently delete your file. But in fact, so when you delete like that, it just deallocate the block to this file. Okay? But the block list is not clean. Okay? So when you create a new file, if you allocate this block to new file, now you overwrite on this block. So at this time, you lose permanently your data. Okay? So that's why if you don't overwrite on this block, you can recover after deleting. Okay? So any question? So this handling we can use so for example, so you see here, return to the acyclic rock directory. So you see here, this one you can use a handling. Okay? You point to the same file like that. Okay. So that's all I want to know in the first chapter. Protection here, CS4, so we already used in the first lab. Okay, for example, when you write your CS3, you must use CS4 to change the permission. Okay, to make your file executed. Okay, so if not, we cannot execute your file. Okay, any question? No? So for file system, we have two chapters. First one, the file system interface, and the last one, so file system implementation. In this one, so we have continuous allocation. We have some method of allocation. For example, continuous allocation, link allocation, and index allocation. And we have also the free space management. So we use for methods. For example, bit vector, list, counting, and grouping to manage the free space. Okay. So for the implementation, so first, okay. So here, file structure. So logical storage unit, okay? File system. File system resides on the secondary storage will have the same. Okay. So this one with the same diameter. So let's make a solid. Okay. So something wrong. Okay. So now, for example, you see in directory structure total. The first block is 0, for example. So now we have a sector, and consider a sector is also a block. Okay, and this, for example, 0, 1, 2, 3, 4, 5. So now this we say, okay, total is 0. So this is the first block. So now, and after that, equal something. And at the last layer, so it's understand that one that to read this total, so you must read this one on the try one. For example, you can try 1, you can try 2. Okay? And the 0 on the track, the sector number, okay, the sector number, the track number, the cylinder number, the track number, okay, to move the arm on the correct position. Okay, so this is on the last layer. Okay, after that, we have here in the basic file system. So in the basic file system, you see this one. Okay, so this consider as the LDA, block address. Okay, so block address. Okay, so this means that now we have many drive, so we number from 0. Okay, so if we can represent 100 sector on this drive, so this will be number from 0 to 90. Okay, in the next drive, so this will be 100 to 199. Okay, each drive will have the same number of sector. Okay, after that, now if in the basic this one, so it means that we translate this one into device driver number that it can understand. It means that, for example, now you give the block for 150. So it must understand that this address belongs to the drive 2 and convert into the sector number, truck number, cylinder number on the drive 2. Okay? And after that, transfer this information to device driver. Okay? So, and after that, you have another one. So, we have a file organization module, okay, translate logical block to physical block, okay, and manage free space, logical file system, okay, so I'm not in Unix system, okay, so and here you see we have many layers like that. We use this layer to manage and in level, okay, so what we do in this layer, so here. So, for example, if you say boot control block, rolling control block, or sometimes we call it a super block, master file table, and directory structure. Okay, so now you see. This is an example of our list. We can divide our list into partition. What's the NUR? record. Okay? So when you start your machine, this session will be response. Okay? And partition. For example, you divide your list into partition. One partition for Windows, one partition for Linux, for example. Or you can split like that. Two partitions for Windows, but you install for the operating system, the system on the partition C, for example. The partition D recognized by Windows 2, but you use the partition D for data. Okay? So, now, it means that some partition we don't have the operating system. Okay? C and D for Windows, but we install the operating system on C. So it means that on the partition C, we will have boot sector, but in partition D, we don't have boot sector. Okay? When you start your machine, the MDR will be with first, and it will locate the boot sector. Okay? And after that, you will have the root border. Okay? Show on operating system in your system, in your disk. And you select which operating system that you want to start. And when you choose, it will read the boot sector to load the operating system. Okay? So boot sector is only in the partition if you use this partition to install the operating system. And the partition control block, so this is the volume control block, it will manage the information of a partition. For example, the number of blocks, okay, on this partition, the number of trace blocks, okay, the number of occupied blocks, and other. So after that, FCD, file control block, and file and directories. Okay? So now you see here we have a partition, and in this partition we will have all information like that. So our file and directory will be here. FCD contain the metadata of a file. Okay? So this we call the metadata of a file. File permission, file J, file owner, group ACL. ACL this is access control list. Okay? So it means that this file can be used by the tool. Okay? So by process ABC, for example, and what you do with your file. So normally when you create a file, so you are owner, so you will have full control. Okay? The guest, you can only read only. Okay? And after that, you can grant your permission to some user. So, in memory file, so I want to show you this one. System open file table and word process open file table. If you only say open file table, so normally it's talk about the system wide open file table. Okay? So return to this one. So you see FCD, file and directory. So we will have directory structure to keep the information up on file on directory in partition. This means that we will have a long list. Okay? So now, if we want to open a file to do something to read to write, okay? This means that you must set the information of this file in your disk. It's in your directory structure, and it takes time. So that's why we have this one. This one. Open file table. So each time you open But when you use hash tables, you can use like the hash version to get information directly by use hash value. But the problem we have collision. An example of the collision when we use hash table, what is it? So we can use birthday example to illustrate for the collision when we use hash table. We have only 365 days. Okay? And it means that in our university, many students will have the same birthday. This means that many students will have the same hash value of the birthday. So this is just an example to illustrate the collision. So now about the allocation, we have three methods for allocation: contiguous allocation, link allocation, and index allocation. This is the first one, contiguous allocation. What is it? So the contiguous allocation is mean that it's find occupied set of contiguous blocks. Okay, best performance in all cases. Simple. Okay. Problem include finding space or file, knowing file size, external fragmentation, need for production of line. So this is this. So this is an example. Allocation. You see, this is directory structure. So we have file name. We have start. This is the first block of our file, and the length. So the number of blocks we use for this file. So for example, count start from 0 and then 2. So this means that the block of this count is 0, 1. Okay, starting from 0. So 0, 1. Count. For example, list, the file list, starting from 28 and we have 4 blocks for this file. So 28, okay, from 28, 1, 2, 3, 4, including 28. So we have 4 this block of this file. Okay, so we say the weakness of this one is external fragmentation. 1. Now, if you count the Y cell, the Y cell here represents that we have a free block. Okay? So, if you count the number of Y cells, so it's more than 10. Okay? But they are not contiguous. So now if we have a request of 10 blocks for a file, so we can allocate. No, because they are not contiguous. So this is the problem of external fragmentation. And another one, how to extend. So for example, this tier. So after 16, we have 2, 3 blocks, 17 and 18. So this means that you can use these 2 blocks to extend tier. But the problem, if after that you use 16 and 18, you cannot extend more. Because we don't have free space after that. So this is the limit of extend. Okay? So this is the problem when we use contiguous allocation. The benefit. Normally we must analyze the benefits first. Okay? The benefit. So random access. So for example, now I say that I want to read the certain block of the file list. So where is it? The certain block of file list. So the certain list is mean that the index 1. This goes we have 0, 1, 2, 3. Okay, so the certain block so this. The starting position is this is 28. Okay? we want. Okay? So the sequential, if we use sequential access, this means that to read this one, we must read this one first. Okay? And then we read this one. So it takes more idle tasks when we use sequential access. Okay? Another benefit. For example, count 0 and 0, 1. So we use these two sectors for count. Okay? So it means that now to accept the file count is HDD. So this describes for HDD. Okay? Not SSD. So here we have the arm. We must move the arm. We must move the arm to this cylinder. Okay? And now, fortunately, we have so under the head. Okay? So we don't move the arm anymore. We just stay there and we wait till this move this one under the head. Okay? So it depends on RPM, the round per minute. Okay? So we have, if we have, normally we have this, after that we have this one. Okay? So this is on the HDD, not on SSD. Okay? So this what that's why we say that if we use continuous allocation, we can read file faster. Because we don't spend much time to move the arm. We move the head under the cylinder we want. Okay? So we take this move. Okay? So, but we had a problem of external fermentation, difficult to explain, and now to solve this problem, we must use the combustion. So, what does it mean, combustion? We move the data in one direction, left order free, and it takes hours to copy data. Okay? So you already use this defragmentation tool? No? No. If you use this tool, so it will do the combustion, but it takes hours to do. Okay? So it's step-by-step system to solve the problem of external fermentation. So a file can be combined by many steps. So what's the on step? On step is a continuous block of disk, and a file can be the combination of many steps. For example, return to this one. So now if I say that I had a request of 10 disk block, so if we use to the next. No. So, we go to the next one. So you read? Okay. Find s as in pointer. No external fragmentation is event. Okay? X block contains pointer to next block, so this is just a characteristic. No combustion external fragmentation is event. Okay, because we don't have external fragmentation, it means that we don't need contiguous allocation, and it means that we don't have external fragmentation. So we can access randomly, directly. Yes or no? Yes. Because based on the index group, we have the information up on the list here in order. Okay? So it stands for direct access. So we still have the internal fragmentation. Where does the internal fragmentation take place? The index group. Why? So you see, we must use a block to contain this information. So if we have a very, very small file, for example, it's only 2 entries. Okay? So an entry here, so you consider we cost 1 byte for each entry. So this means that if you have 2 blocks, you need only 2 bytes to contain the information. And it means that we waste a lot of space here. Okay, so this because the internal fragmentation in the index code. Okay, when we have a small file. And when we use the index allocation, when we want to read the data of file, so you must post two blocks read. Why? Because you must read the index code. to block contain data. So after that we have indirect block 20. So it means that the block 20 does not contain data. It contains pointer, the block number. So 20. Okay, you don't have data here. You have block number. Okay, so you have 25, 26. So 25 and 26. So the data will be in 25 and 26. Okay? Double 30. Okay, so block 30 does not contain data. So 30 where? Okay, 30 here. So we have indirect block 38, 39. So indirect block does not contain data, contain the block number. So that's why we have block number. And this block number point to data block. So this means that 9 and 90 contain data. Okay? So this is an example of item. Okay, so which we use in unit system. So in the file system in ST. So and question. So exercise. So read carefully the description. So you calculate the lattice size of a file. So we do it. How about single liquid?
Câu hỏi gì? Câu hỏi là mày làm cái công việc gì là con bao nhiêu cái lá chỉ cái file cái lá chỉ file của mày là bao nhiêu với cái điều kiện đó.
Cái lá là file lớn nhất nè. Mày sử dụng tiếng Việt thì được không?
Tao sử dụng tiếng gì? Cái
Mày sử dụng tiếng Việt để đọc tiếng Anh như cái